Okay, so this is reduction of acidic halides. Um, this organotins continuation. Let's give an entry. Right. Okay. I think somebody is waiting. I think no one is waiting. Right. So continuation of organotins, more particularly the application of organotins in organic synthesis. So reduction of acid halides. So reduction of acid halides. Here, you know that RCOCl is called acid halides. Okay, reduction of acid halides. Right. Okay, fine. So this is HARCOCl means acid chloride. Okay. So Har may be a alkyl group or may be a aryl group. So when it is treated with tributyl tin, so here tributyl tin will act as a source of hydrogen. So what it will do, it replaces Cl with hydrogen. So that means what is the product obtained? The product obtained is an aldehyde. That means it is possible to convert acid chloride into aldehyde with tributyl tin. And so look here, of course, this is also a what is called as acid halide. But in addition to the formation of aldehyde, it also leads to the formation of ester. So how the ester is formed? By the combination of aldehyde and then the radical obtained by the acyl radical. So during this process, acyl radical is generated. That acyl radical react with the hydrogen radical, then it's forming an aldehyde. So once there is a formation of aldehyde, this aldehyde again react with the radical, acid radical, means acyl radical, then there is a formation of ester. So these two are the general reaction. So general reaction means acid chloride, when it is treated with tributyl tin hydride, it gives anhydride. Similarly, acid chloride, when it is treated with tributyl tin, it gives an ester. Okay. So with this, I will go to the next slide. So look here, next here I am explaining about the mechanism. So tributyl tin. So this tributyl tin, when it is exposed to a light or what is called as a radical initiator. So radical initiator, it will create a radical. That radical react with the tributyl tin, and that gives you tributyl tin radical. Tributyl tin radical react with the acid chloride. Here there will be a homolytic cleavage and giving rise to acyl radical. This acyl radical, when it is react with the tributyl tin, so the bond between the tin and hydrogen undergoes homolytic cleavage and liberate a hydrogen radical. That hydrogen radical react with this acyl radical, forming a aldehyde. So this is how the aldehyde is obtained. Suppose acid means what is called as acyl radical. Let's give an entry. Right. This is an acyl radical. Acyl radical, when it is treated with aldehyde. So you know that the bond pair, okay, a carbon and oxygen bond pair. So that undergoes homolytic cleavage. It means that there will be a new bond formation between this oxygen, the radical, and this carbonyl carbon radical. So carbonyl carbon radical. Right. Okay. So if there is a bond formation between this oxygen and this carbonyl carbon, so there will be a formation of what is called as ester. But there is a radical here. So this radical again react with the hydrogen radical from a tributyl tin hydride. So that is how an ester is obtained. This is about the mechanism how the tributyl tin hydride converts an acid chloride to aldehyde as well as a ester. So next we will take an examples. So how the percentage of aldehyde, what is the percentage of aldehyde is obtained, what is the percentage of ester is obtained. So we'll go to that one. So look here, I'm taking a benzoyl chloride, BenZoyl. So CO stands for benzoyl, OYL, okay, benzoyl chloride. So when it is treated with tributyl tin hydride, so this bromide is replaced with hydrogen. How it is replaced? So this undergoes homolytic cleavage forming a benzoyl radical. That benzoyl radical react with the hydrogen radical forming a benzaldehyde. Similarly, benzoyl chloride, when it is treated with tributyl tin, so what is happening? It is observed that in addition to the aldehyde formation, it also leads to the formation of ester up to 35% and 65% aldehyde is obtained. So that means 1 gram means 0.65 gram of aldehyde, 0.35 gram of ester. More particularly with respect to the mole. Okay, mole means you know that what is mole. So I am taking one more example. This is an aryl. C6H5 is an aryl, but here I am taking a propyl C3H7. It's a propyl. So here the name is wrong. You need to correct it. This is a propyl. So this carbon means butyl. Then butyryl chloride. Name of this compound is butyryl chloride. This is not a benzoyl chloride. So benzoyl chloride is this. Butyryl chloride, when it is treated with tributyl tin hydride. So what it will do? There will be a homolytic cleavage. So there will be a homolytic cleavage forming a radical. That radical react with the hydrogen radical, forming a aldehyde of 13%. The formation of aldehyde in alkonyl. How do you differentiate aryl? This is a benzoyl, and this one is aryl. Okay, aryl is a general name for the benzoyl, means what you call aryl ketones. This is alkyl ketones. Okay, it's not a ketone, alkyl acid chloride, aryl acid chloride. So, in the case of aryl acid chloride, aldehyde will be the major. In the case of alkyl acid chloride, aldehyde will be the less quantity, whereas the ester will be the more quantity. That difference you need to remember. So this is about the examples of reduction of acid chlorides. So with this, I will go to the next slide. Okay. So here, reduction of carbonyl compounds. The addition of the, this is the reagent. Addition of the reagent across the double bond. So what it means, hydrogen will add to more substituted carbon atom, tin will add to oxygen metal. So that is how an intermediate is obtained. This intermediate on hydrolysis means breakage here. So that is how an alcohol is obtained. What it means? It means that carbonyl compounds may be a ketone or ester. Okay, a carbonyl compounds, more particularly ketone, is the best results you can expect. A ketone, the ketone may be a mixed ketone or a simple ketone, or symmetrical ketone or unsymmetrical ketone. So ketones are converted into alcohol by treating with tributyl tin hydride. See, similarly here I am taking examples. I think you are aware about the canonical, what you call conformational analysis. So here the what is called as a bulky group is attains a what is called equatorial position. This is axial, this is also axial. So when this hydride will add to this carbonyl group, this O means oxygen and tin will occupy a equatorial position because it's a bulky group. So that is how equatorial hydroxy is obtained. So this is about as far as when conformational cyclohexanone when it is treated with tributyl tin. So with this, I will go to the next slide. So look here, reduction of cyclic secondary alcohol. So this is a alcohol. Of course, it's a secondary alcohol. What will happen? So this, when it is treated with a compound, what is the name of this compound? It's a double bond and then a chlorine. So what is happening here? The Cl and H is going out. So forming an oxy compound. This oxy compound, when it is treated with H2S, H2S is a gas, but it can be generated and it can be purged to the reaction media. So what will happen? This N is replaced by sulfur. So this is the compound. It's a thioester is obtained. This thioester, when it is treated with tributyl tin hydride. So what it will do? So hydride will add to this carbon. Then this is going out. That means thiobenzoic acid is the living group and hydrocarbon is the product. What it means? So it means that alcohols can be converted into hydrocarbons, removal of dihydroxyl group, okay, can be achieved by using a tributyl tin hydride. Okay, so with this, I will go to the next slide. So look here, I am taking one more example. So reduction of alkenes and alkynes. So this is an alkene. So this alkene, when it is treated with tributyl tin hydride. So here AABN is a what is called as a radical initiator. So in addition to the radical initiator, sulfur is also added. So this sulfur also acts as a radical propagation step. So once the radical is initiated by AABN, so that can react with the sulfur and sulfur can form a sulfur radical. That sulfur radical can react with the tributyl tin hydride and giving rise to butyl tin hydride radical and neutral molecule. SH is a neutral molecule, it will go out. So once tributyl tin radical is formed, that will react with a double bond. So more particularly, electron withdrawing containing double bond. So there will be a radical formation like this. Of course, what will happen? There will be a new bond formation between this carbon and the tin. And this ion, when it is treated with one more equivalent of tributyl tin, so there will be a product formation like this. So this is about what is called as how the what is called alkenes. Okay, alkenes. How the alkenes are react with tributyl tin hydride. It's nothing but a new bond formation between the alkene carbon and the tributyl tin. Okay, so with this I will go to the next slide. So next slide is about the few examples I am taking. So look here, this is an ethyl ester, this is a benzyl group. Of course, a double bond is there. So this is the one where there is a reaction occurs. These two are substituents. Okay, so then what will happen? This tributyl tin hydride, when it is added to double bond, there will be a new bond formation between this carbon and this tin. So that's what I have written the product, and this double bond is converted into single bond. Similarly, here instead of C6H5, here there is a CH3. That is the difference. The reactive species is same. Reactive species is a double bond. This double bond reacts with the tin. So there will be a new bond formation between this carbon and this tin. And this carbon is attacked by H radical. That means double bond is converted into single bond. These are the two examples of what happens when a alkene or alkyne react with the tributyl tin. So with this, I will go to the one more kind of reaction, that is a reduction of nitro group. I think you are aware about the nitro group. So this is a nitro group. This a tertiary or secondary aliphatic nitro groups is replaced with hydrogen. That means removal of nitro group. Nitro group can be removed, or a nitro group can be replaced with hydrogen. So with this, I will go to the next slide. So deoxygenation of alcohol. So deoxygenation means removal of oxygen. And this is about Barton-McCombie reaction. It's a name reaction. Barton. I think you are aware about the Barton decarboxylation. So the Barton decarboxylation I will explain maybe over a few slides. But here I am talking about Barton-McCombie reaction. Then what is the Barton-McCombie reaction? It's nothing but a reaction of alcohol with sodium hydride. So what it will do, sodium hydride, it will form an anion here. So O minus is obtained. That O minus react with electron deficient carbonyl carbon. So that means it will form a compound like this, O, C double bond S, S minus. This S minus, when it is react with an electrophile like methyl iodide, so there will be a thioester formation like this. Once there is a thioester formation, this moiety is treated with a tributyl tin hydride. So in this tributyl tin hydride, there will be a homolytic cleavage between the tin and hydrogen. There will be a homolytic cleavage between the carbon and sulfur. So what will happen? So there will be a new bond formation between this sulfur and this tin. There will be a new bond formation between this carbon and hydrogen. Then what will happen? A radical is formed here, because so this bond pair breaks means here radical one form, and this radical form a bond with a tin. So there is a what is called intermediate like this. At this time, this particular bond cleaves. When this particular bond cleaves, here there is a formation of radical. That radical is attacked by hydrogen radical. So that is how an hydrocarbon is obtained. Overall, a alcohol is replaced with hydrogen. So this reaction is called Barton-McCombie reaction. So what are the reagents? Sodium hydride, carbon disulfide, methyl iodide, and tributyl tin hydride. So in any reaction, if you are able to see these reagent, what are the reagent? Sodium hydride, carbon disulfide, methyl iodide, and tributyl tin hydride. So that particular reaction is nothing but a Barton-McCombie reaction. So in the Barton-McCombie reaction, a hydroxy group is converted into hydrocarbon. So that's what you need to remember. So with this, I will go to the next slide. Next slide, I will take you example. Okay, examples of Barton-McCombie reaction. So look here, this is one example. I think you are aware about the fatty acid. Okay, when the fatty acid is reduced, you will get an alcohol. This is a alcohol. Okay, long chain hydroxy group, long chain containing hydroxy compound. So this, when it is heated with sodium hydride, there will be anion formation. So that anion react with an electrophile. So again, S minus forms, that S minus react with methyl. And then that was treated with the tributyl tin hydride, and this OH is replaced with hydrogen. This is, if you want to write the mechanism for a conversion of this an alcohol to this hydrocarbon, you can write. So with this, I will go to the next slide. Next slide, I will take you one a stereochemical example. Okay, so look here. This is a stereochemical example. It's a bicyclic compound. Of course, you can take this as a. Of course, what is happening here? Uh, uh, Maybe you are aware that this hydroxy group, a 2-hydroxy glycol group, is protected with acetone. Similarly, this here 2-hydroxy group, this hydroxy group is protected with acetone. So, okay, that's all. Okay, here there is a 2-hydroxy that was protected with acetone. 2-hydroxy, it was protected with acetone. But here one hydroxy is there, that's a free hydroxy. This hydroxy is reacting with sodium hydride, forms an anion. That anion is attacking carbon in carbon, forms a S minus. That S minus react with this methyl. Okay, forms an thioester. That thioester react with the tributyl tin hydride. And what will happen? There will be a replacement of this OH with hydrogen of tin. So that is what the product is obtained. So this is about what is called as Barton-McCombie reaction. So Barton-McCombie reaction means conversion of an hydroxy group into hydrogen. Not what you can say, that replacement of hydroxy group with hydrogen. How it is replaced? An hydroxy compound is treated with sodium hydride, carbon disulfide, and methyl iodide, followed by tributyl tin hydride. So that will give you a replacement of hydroxy group with the hydrogen. So with this, I will go to the next slide. So look here. So this is called a Barton decarboxylation. Sometimes there will be a questions on Barton decarboxylation. So look here, this is a carboxylic acid, and this is what is called as heterocyclic compound. The one contain an N-hydroxy, and adjacent carbon will have a thioketone. So what is happening? You know that this is an acid, this is an alcohol. So there will be removal of H and OH, removal of water. How the water is removed? By treating with DCC. DCC is a dehydrating agent. So that is how an ester is obtained. So once the ester is obtained, it was treated with the tributyl tin hydride. Of course, this reaction is initiated by AIBN. What is AIBN? Aza isobutyronitride. Aza isobutyronitride itself cleaves and forms a free radical. That free radical one react with the tributyl tin hydride. There will be a new free radical formation, that is tributyl tin radical. That tin radical reacts. How it will react? So here there will be a cleavage. This particular pi bond cleavage forms a new bond with sulfur and a tributyl tin, and there will be a new radical is formed on this carbon. Once there is a new car, here I have shown. This is the new radical form. Once there is a radical form here, this particular bond cleaves in a homolytic fashion. That means this oxygen takes its electron, this nitrogen takes its electron. So what it means? There will be a double bond formation like this. So this is the product of time. What is happening here? So there will be a removal of carbon dioxide. So that is the reason this reaction is called Barton decarboxylation. Okay, I think you are aware about one more thing, no? What is that? Maybe in the uh, uh, what is steroids. Okay, there also Barton scientist name is there. Okay, don't confuse with the this Barton decarboxylation and aldosterone synthesis Barton reaction. Okay, there all okay. That is a different reaction. This is different reaction. So this is about what is called as organotins. Okay, today we discussed about application of organotins, more particularly in the conversion of acid halides to aldehydes. Sometimes acid halides converts aldehydes as aldehydes. In addition to aldehydes, it will also convert into a ester. Okay, and in addition to that, we also discussed about two name reaction. One is Barton decarboxylation and another one is Barton Mecumbi reaction. So this is about today's class. Maybe a remaining thing I will take in the next class. So what you can do, maybe if you have a doubts, you can ask me, and if there is no doubt, you can log out.